All right, everybody, this is a guided walkthrough for the TriplAdvisor machine on the HackMyVM.eu website. All right, so this is a Windows machine, and there are specific hacking methods that we have to do specifically for Windows, and I'm going to be demonstrating those in this little demonstration. So the first thing we need to do is we need to identify. Let me close out Burp Suite over here. And we need to identify where on this network this machine is. So let me go into the temp directory. We're going to use the nmap program to figure out where on the network this virtual machine is deployed. So we're going to run nmap with the -sn flag, which is going to do a ping sweep. Ping sweeping is basically finding out which machines are online on a specific network range. So we've got this network range here. We're going to figure out which machines are online and identify which IP address we need to hack against. So we see that we've got address 1, 2, 15, and number 6. Number 6 is our attacking machine's IP address. So this is the IP address we're going to be hacking against. So I'm going to copy that. And let's run another nmap scan. So nmap is a program we can run to figure out which ports and services are available on particular servers. And in this case, let's run it with getting all of the common scripts and versioning information. And as well, we can let's do T5, so for a very quick scan. Okay. So we see here we've discovered port 445 and port 8080. 8080 is unusual, but 445 is pretty normal for Windows machines. We're going to be talking about what types of ports and services we discover on this machine in just a little bit. So port 445, in case you don't know, this is the port that's associated with the SMB service, which is basically Windows file sharing. We discovered port 8080, which is usually some sort of proxy server, HTTP server, and we discovered 5985, which is associated with the Windows remote management protocol, which is basically something that administrators can use to log in and get terminal access. So are these the only ports that are open on the system? I haven't done this in a little while. So first of all, we could probably figure out what is happening on port 8080, and this is probably some sort of web server. So we're just going to grab our IP address here, and we're going to try to access the web server on this port here, 8080. We're going to go over to our web browser. We're going to go to this IP address on port 8080. So to access a specific port inside the web browser, you just need to give the domain or the IP address, and then give a colon. After the colon, specify the port that you want to access, and then hit enter. Okay, so what this did is it redirected us. So it redirected us to this domain right over here called TriplAdvisor. So this means that we were not able to resolve this domain because it's not in our DNS. But we can actually associate that IP address with this domain here called TriplAdvisor by going into our Linux etc. host file. So I'm just going to get out of the web browser, and then in another tab, we're going to edit our etc. host file. So the etc. we need to specify a program. We're going to use nano to edit the etc. host file. So the etc. host file basically lets us specify what domains are associated with what IP addresses. So we can specify that the the IP address of the Windows machine, which is 192.168.200.15. We're going to associate with that with the TriplAdvisor domain over here. So when we use TriplAdvisor in the web browser, it's gonna resolve to this IP address. So we can go ahead and save this out. And after this is saved, when we type in TriplAdvisor into our web browser, it's going to resolve to this IP address, and we're going to be able to see the actual website. Okay, so now that we have that saved, we're going to go back to our web browser, and then we're going to try reloading this page. Okay, so this looks like some sort of best travel online guide over here. Ah, okay. So we see here that we're also dealing with a WordPress installation. So WordPress is a content management system. It's a very common content management system that is used for creating blogs and other web pages like this. So we know that we're dealing with WordPress because inside the address bar here, it goes to the WordPress endpoint over here. So it's TriplAdvisor :8080/WordPress. So WordPress is a very popular content management system, and there's actually a tool that is used to scan for security flaws against WordPress. So let's go ahead and try using that. So the program is called WP-Scan, and you can use WP-Scan to scan for all sorts of different security configurations on WordPress sites. So we're going to give WP-Scan and run it rather quickly, and we're going to enumerate the what are these called? They're called modules, I think. Are they called plugins? Yes, we're going to enumerate the plugins on this particular WordPress site. So we have to provide the URL, which is TriplAdvisor :8080 WordPress. So let's go ahead and run the WP-Scan tool. It's going to go ahead and scan this website over here for different WordPress security flaws. In particular, it's going to take a look at the plugins. Okay, so we see here that it's going to give us a lot of output. So it found some interesting findings. So it found some headers. It found some different configuration settings, such as XML RPC seems to be enabled over here. Let's see, it found a README file. It found an upload directory with listing enabled, which means that anybody can take a look at the contents of the directory. And what else? So it found some authors. So the name of an author on this article, Drake Arthur. So we were also looking at plugins. So we found this particular plugin over here, the editor plugin, and we were able to find a version for this particular plugin here. And oftentimes, WordPress plugins of a certain version will be vulnerable to software exploits. All right, so what we can do, because we've identified this particular plugin with this version here, we can do a little search for known exploits. So we could do search exploit WordPress editor 1.1. Okay, so we managed to use search exploit to look for an exploit here, and we found a couple. So we've got local file inclusion, and we've got privilege escalation. So we don't need privilege escalation at this point. So we're going to be more interested in this local file inclusion vulnerability here. And we can actually take a look at the file over here. It looks like a TXT file by running search exploit with the M argument. So it's going to be search exploit M and then the number over here. So search exploit M and then 44340. It's going to download that file to our current directory. And from here, we can just take a look at the file and see what's going on. So it says that this is a local file inclusion vulnerability in the site editor plugin through 1.1.1 for WordPress. It allows remote attackers to retrieve arbitrary files via the Ajax path parameter to editor/extension/page builder/includes/ Ajax shortcut pattern.php. So what this is it's a local file inclusion vulnerability, and I've got a presentation for this. Hold on. Let me grab my presentation. Okay. So what we're going to be doing here is we're going to be using local file inclusion for an attack called log poisoning. So first of all, let's talk a little bit about local file inclusion. Local file inclusion is a vulnerability where we can read files by including certain URL parameters on a web app. And before we talk about log poisoning, we should probably confirm that we have local file inclusion. So we've got a path over here that we can follow. So we would go to the website, to the /editor/extension/page builder/include/Ajax shortcut pattern over here. And what we can do is we can make sure that we have local file inclusion by going to that particular endpoint. So this endpoint over here, so TriplAdvisor, WordPress, WP content, plugins, editor, extensions, page builder includes Ajax short pattern, blah, 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 blah. And what they're looking for is this particular, what is it called? URL parameter here. So it's Ajax path equals, and then whatever file we want to read. So local file inclusion lets us read files on the web server, but not files that are intended to be read on the web server. It's basically any file on the web server as long as we have access to it. Anyways, let's try reading the etc host file on this Windows machine. Okay, so this is an etc host file on a Windows machine. It's located at C Windows System 32 drivers etc hosts. So if we wanted to take a look at this in a slightly prettier format, we can always go ahead and view the page source. And when we view this in page source, then the formatting is going to come back and it's going to be much more readable. So the fact that we can access this particular file through local file inclusion is proof that we have read access to any file on the server as long as we know where on the server it exists. So we're going to use this, and we're going to leverage this with another vulnerability called log poisoning in order to get code injection on the system. So let's talk a little bit more about that. So over here. So we're going to be doing a log poisoning attack. Log poisoning is a web app hacking attack where we can inject code into web server logs and then activate that code by accessing the log files with local file inclusion. So basically what we're doing is we're introducing some code into the logs for the web app, and then when we access the logs through local file inclusion, we're going to execute the code, and we're going to be able to run commands on the server. Okay, so when performing a log poisoning attack, the first step is to make sure we can access log files via local file inclusion. So we need to make sure that we can look at the logs on the server, and we're going to do that through local file inclusion. We're going to go over here, and instead of looking at the etc host file, we're going to look at the C XAMPP/Apache/logs/access.log. So this particular system is running a XAMPP stack, which is a bunch of technologies on top of each other and includes running an Apache web server. And if it's running a XAMPP stack, then the logs are going to be located at C/XAMPP/Apache/log/access.log. So we can take a look at the logs file over here, and these are all of the access logs. So every instance where the web server was contacted, it keeps track of all of these in this log file here. So what's the second step? The second step for log poisoning attack is to inject code into the web server logs through an HTTP request. So what we can do is we can just access the server in a kind of sneaky way to introduce code into the logs. So in this case, we're going to use curl. Let me grab the command. Okay. So we can go back to our terminal here. Don't need this anymore. And in the terminal, what we're going to do is we're going to use curl to send a request to the web server. So this is the web server here, HTTP TriplAdvisor on port 8080 WordPress. And we're going to use curl to send some data. So we send data with curl using the -x over here. And we specify what data we're going to send afterwards. So inside here, there's some PHP code. And because this is an Apache server and WordPress runs with PHP, we know that the server runs PHP code. So we can introduce this little snippet of code here to create a web shell inside of the logs endpoint. So PHP echo pass through get command. So basically, we're going to set up a URL parameter, which is called command, and through that, it's going to run the pass-through function, which is basically running OS commands. So in this way, we're going to introduce a web shell to the log file. Okay, so we're going to go ahead and run this curl command to introduce the poisoned log, rather. Okay. So we were able to send the information here using curl, but we got some sort of error message. So it says here that your browser or proxy sent a request that the server could not understand, which means that this particular request is going to be filed as an error. Okay, so let's go ahead and go over to the web browser, and inside here, this is these are the log files. We're going to refresh the page. Did we refresh the page? And let's hold on. Let me refresh the page one more time. And let's search for the code that we introduced. So we introduced pass through. So let's search for pass through. Hold on. Oh, it didn't. It's not here. Okay, this is probably in the error logs. Let me go ahead and, instead of the access logs, we're going to take a look at the error logs. And let's search for this pass-through here. Phrase not found. Let me go back to the access log then. Access.log. Oh, wait. Here's the thing. Okay. The reason we can't find it in the logs is because we're not going to be able to see PHP code in the we're not going to be able to see PHP code in these logs because it's going to be interpreted as PHP code. Sorry, my bad. Let's go ahead and try to access the web shell. So the way we would access the web shell if there is PHP code embedded in here is we would go ahead and over at the end of the URL here, so access.log, we can add another URL parameter. So the other URL parameter we're going to do and cmd equals some command. So I can do and cmd equals dir, and that's going to get the contents of the directory that we are working inside. So let's give that command, And we can see here, okay, so we were able to successfully poison the logs of this particular web app, and we're able to get it to run this command over here, the dir command on Windows. So we can see all of the contents of the current working directory that the Windows. So this confirms that we're able to execute commands on the web server because we introduced a web shell to the web app. All right, so the next thing we need to do is we need to figure out a way to break into the web server. So what we're going to do is we're going to upload some files. So we're going to use the web shell, and we're going to upload the netcat binary so that we can start using the netcat binary to give us reverse shells. So first of all, one thing we can do is we can locate nc.exe, which is the Windows version of netcat. And it's going to be over here in this directory here. So user share seclist web shells fuzz netcat.exe. So I'm going to copy this over to our local directory. So I'm going to do cp and just like this, copy this file in this directory over to our current directory. I'm going to run that. And now we see that nc.exe is available in our current directory. We're going to serve this up by starting up a Python web server. So we're just going to run python-m http.server on port 80. And this is going to start a web server in this current directory, which has the netcat.exe file. So from here, what we're going to do is we're going to use the log poisoning attack to into the web shell to download the netcat.exe binary to the target. So I'm going to use this command. Hold on. It is the certutil command. And let's talk a little bit about this command. So the command is going to look like this. So certutil is a program on Windows systems that can be used to download files. So we're going to use certutil URL cache -f, and we're going to have the program reach out to our attacking server, which is located at this IP address here, and we're going to save the netcat.exe binary into the current directory as nc.exe. So we're going to go over to our web shell over here, and we're going to give the command here. So I'm just going to paste in the certutil command here. Okay, so we're just going to give this command here to download the netcat binary to the Windows victim server. Okay, so we do that. And let's take a look if there's any output over here. So it says here, certutil URL cache command completed successfully. So it was able to download the netcat binary. So if we look over here on our Python server, the Python server also shows a log that nc.exe was downloaded. Okay, so from here we can confirm that that the file exists on the web server by giving the dir command through the web shell. So we're going to give the dir command, and we're going to see that all the way down here inside the directory that nc.exe is on the web server now. So we can run the nc.exe binary from the web shell and then get a reverse shell. Okay, so in order to do this, we're going to go over to another terminal, and we're going to set up our reverse shell listener. So we're going to use rlwrap to give our netcat shell some additional capabilities, and we're going to start up our netcat listener on port 443. Okay, so now that we have the netcat listener listening, we're going to go over to, we're going to give the netcat command that is going to give us our reverse shell. So let me, this is it. So this is the command we're going to run through the web shell. So netcat.exe, and then our attacker machine IP address over here, on port 443, it's going to execute the cmd.exe command. So this is going to give us our shell. So let's go ahead and, well, we have this copied already. Okay, let's go over to our web shell and let's run that command. So up here, we're going to paste in the command, hit enter. Didn't load shortcodes pattern file. I wonder what happened here. Let's take a look and see if our reverse shell got caught. No, okay. I think what went wrong here? Ajax path was the same. Oh, no. Okay. I made an error. I put the command in the wrong place. So command equals. I need to do it over at the command equals place. Okay. So I'm just going to give the command, and we see that we got some regular output over here. So we're going to go back and see if the netcat shell was caught. So the netcat shell was caught, and we managed to open up a connection over to this IP address, which is the victim machine, and we now have a Windows command prompt. So if we ask who am I, we don't have who am I. So the who am I binary actually doesn't exist on this target. What we're going to do is we're going to upload our own Windows binary for who am I, and then we're going to figure out which user we are. So from here, we're going to move into the C users public directory, because this directory is usually writable and readable by any user. So if we take a look in here, there's nothing in here. Well, there's some directories in here, and we're going to upload a who am I binary so that we can actually start using it and figure out what user we are and what permissions we have. Okay, so over here at the Python server, we're just going to disable the Python server for right now, and we're going to locate whoami.exe. So this is the Windows binary, and we see it is over here on our Kali box. We're going to copy it over to our current directory. And now we've got the whoami.exe binary here. We're going to start up the Python web server again, and then we're going to download the whoami.exe binary to our target. So over here, we're going to use certutil again. So this is the certutil command. We're going to download from our attacker IP the whoami.exe binary, and we're going to save it to our current directory here. So we're going to do that. Okay. And now we see that whoami.exe is in here, and we can finally figure out who we are supposed to be. So if we type whoami, we should be able to figure it out. We are the TriplAdvisor web service user. So the important thing to understand about Windows privilege escalation is that sometimes the privileges that a particular user has can be leveraged into privilege escalation on Windows. And we're going to run this command over here, whoami/priv, to figure out what privileges they have. So we see these ones over here. We've got these three. But in this case, this is a pretty common vector over here. We've got these three privileges. We have SE change notify privilege, SE impersonate privilege, and SE created global privilege. So the one that we need to pay attention to is this. So we have SE impersonate privilege, which impersonates a client after authentication. So this is a very common type of privilege escalation vector inside of Windows, especially for older machines. And let's talk a little bit about this. So we're looking at, here we go. Okay. So privilege escalation, SE impersonate privilege. So the SeImpersonate privilege is a feature which allows a user to perform commands in the context of other users. So you can think of it as something kind of like the sudo command or the do as command inside of Linux. So this privilege is typically associated with service accounts like IIS, SQL Server, and with administrator accounts. So using SeImpersonate, attackers can elevate privileges to system or administrator level either through token theft and or named pipes. And a common type of exploit that is used to elevate the privileges is something called the potato exploit. So the potato family of Windows exploits all leverage the SeImpersonate privilege in different ways to achieve elevated access on Windows targets. So which potato exploit to use on a target largely depends on the version of Windows being used. And in this case, we're going to be using the juicy potato variant. So if we want to know which version of the potato exploits we want to use for a particular version of Windows, there's actually a very useful article over here. So I think, let me see if I've got it handy in my notes. So basically, it talks about the different types of Windows potato exploits over here. So we've got hot potato, rotten potato, lonely potato, juicy potato, rogue potato, sweet potato, generic potato. So the TLDR of this entire article over here is that if you don't want to use sweet potato, so I guess sweet potato is one of the variants. If the machine is let's see, is greater than or equal to Windows 10, we use rogue potato. But if the machine is less than Windows 10, we use juicy potato. So let's go ahead and use juicy potato. So juicy potato, let's look this up. So GitHub, juicy potato. All right, so we've got this. We got this server over here, and we've got the juicy potato exploit. And it's advertised as a sugared version of rotten potato ng, but with a bit of juice. Another local privilege escalation tool from a Windows service account to NT authority system. Okay, so what we need to do is we need to get a binary. We need to get a binary with the juicy potato exploit, and we can do so from this link over here, from releases. So we've got the juicy potato exploit binary over here. We can go ahead and copy the link, and then we're going to go back to our Linux file HTTP server. We're going to shut that down just momentarily, and then we're going to wget and download the juicypotato.exe binary. So after we've done that, we see that juicypotato.exe is now in the directory here, and we can start up our web server again. So we're just going to download juicypotato.exe from our attacker machine, and then we're going to run it to get super user privileges on the system. You'll know that you can use a potato exploit, maybe not a potato exploit, but some sort of exploit if your user has the SeImpersonate privilege over here. So you can use this command whoami/priv, and if you see that you have SeImpersonate privilege active, then you can usually use a potato exploit to gain privilege escalation on a Windows target, especially if it's an older version of Windows. It's less likely on a newer version of Windows, but on older versions of Windows, and we can figure out what type of Windows is running by using the systeminfo command. So systeminfo is going to tell us all about what kind of Windows is being run here. So this is Microsoft Windows Server 2008 R2 Enterprise. So it's a pretty old version of Windows. And another thing we need to take note of is that it says this is an x64 based PC. Sometimes, especially with really old version of Windows, you'll occasionally find that the processor that is being used is going to be a 32-bit processor, and that really affects what kind of exploits you can run on the system. So 64-bit exploits need to be run on 64-bit systems. And 32-bit exploits can only be run, well, 32-bit exploits can be run on 64-bit systems, but not the other way around. So this is just something you need to keep in mind. Okay, so now that we know what kind of environment we're working with, we can upload the Juicy Potato exploit. So we're just going to use certutil again to download that file. So let me modify this command. So instead of whoami.exe, we're going to download juicypotato.exe, and we're going to save it into this directory as jp.exe, just because I don't want to type out juicy potato each time. So we're going to use certutil to download the exploit file. Okay, and now we've got the juicypotato.exe file here, and we're going to run the juicypotato.exe file, and we're going to use it to get a reverse shell on the target with the NT-authority system privileges. So before we do that, we need to set up our second netcat reverse shell. So we're going to set up our listener. It's going to be rlwrap with netcat on our favorite port 443. So remember, because we've already caught the shell that was listening on port 443, 443 becomes available again. So we can keep on using port 443 as long as the port isn't currently in use. Okay, so we're going to go back to here. We've got the juicypotato.exe file here. And let me demonstrate how to use the juicypotato.exe exploit. So over here, there's a very long command we have to give to run Juicy Potato. So of course there's Juicy Potato here, and then we have to supply a port number that's not being used. So we have to supply a port number that's not being used on the target. And here we're going to give some arguments for whatever command we're going to be running. The actual command we're going to be running is -p, and we're going to run C Windows System 32 cmd.exe. So we're basically going to run this command that runs another command, and it's going to run these arguments here, which is we're going to run the netcat binary that we downloaded to C users public, and we're going to use it to run netcat, contact our attacker system on port 443, and open up a command shell. So the other important thing we have to know about Juicy Potato is that we need to supply a code over here. So the code is associated with different services. Let's see. So when we run Juicy Potato, we have to provide an CLSID for particular services. And the great thing about Juicy Potato here is that they've actually recorded a number of different CLSIDs for different services on different versions of Windows. If we go over to the link, we follow the link over here. We've got Windows CLSIDs for all sorts of different versions of Windows. The version of Windows that we're dealing with today is Windows Server 2008 R2 Enterprise. So we can click into there. And it actually tells us about all of these CLSIDs, as well as the service accounts that are associated with them, and the type of access that we get. For some reason, these tables don't want to play nice on the web browser here. But we see here that we've got a bunch of them, and they're not always going to work on every system. So sometimes you have to try a few different CLSIDs with Juicy Potato and see which one works. So we see here that the user that is provided when we use these CLSIDs are listed below. Of course, the most coveted one that we want to use is the NT authority system, which has the highest level of access on a Windows target. But there's a bunch of other users as well. So what we would do if we run Juicy Potato is we try to use one of these CLS IDs with the that is associated with the highest level user. Of course, if one doesn't work, we can always switch to another one and another one and another one until we find one that works. But here we found one that works over here, and we're going to be using this with Juicy Potato to get us a NT authority system shell. So I'm just going to copy this. We're going to go over to the victim server where we've got the Juicy Potato over here. We're going to paste in the command, and then we're going to execute the Juicy Potato. So we run the command. So it says here, NT authority system. Okay, great. And it's testing this CLS ID on this port. And it says created process with token equals OK, which probably means that, that the command executed. And remember, the command is the netcat command, which gives us the reverse shell. So if we go over to our reverse shell listener, it's still listening. Okay, that wasn't that was unexpected. Let's try that again. Did I? This should all work. We've got all of our stuff in place. So see, oh, there's no netcat command in here. Okay, I need to copy netcat over to this directory. So let's go ahead and do that. The reason why it didn't work is that I forgot to copy the netcat binary over to this directory. Okay, let's download that using certutil. Okay, so one more time. We're going to replace whoami.exe here with netcat.exe, and we're going to download the netcat binary to this directory. Okay, now we've got the juicypotato.exe exploit in here. We've got netcat.exe in here. We have whoami.exe in here. And let's run the Juicy Potato exploit one more time, now that we have the netcat binary in place. Okay, so we get the same message over here, so it should have gone off. Let's take a look at our reverse shell listener. Okay, we got a connection from Microsoft. Sorry, from the target system, which is this IP address over here, and we can't. So whoami is not in this directory, but whoami is in the C users public directory, so we can do whoami from there. So if we ask whoami, it is NT authority system, which means we have full access to the server. And let's call out our good friend Scary Hacker Voice guy to celebrate. Hold on, let's do the voice changer.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out every time we break into a server and get root or administrator access. Well, that just happened. Well, TriplAdvisor web server administrators, it looks like you forgot to patch your web server for local file inclusion and log poisoning. Big mistake. We were able to use both of those vulnerabilities to get system access, and then from there, we were able to use the Juicy Potato exploit to get elevated access, and then we became the super user. We're in.
Okay, so we've got NT authority system access to the server, so we can go ahead and go into any of these user directories. We've got the administrator directory. We can just waltz in there, and ooh, don't have tab autocomplete. We can move into the desktop directory, And in the desktop directory is the root flag, which is the objective for this exercise. So on our live streams, we don't read the flags for these exercises because the organizers have asked that we do not reveal flag contents. So what we're going to do instead is we're just going to use the command type root.txt, redirect it into another file called iReadRoot.txt, and then we see that we've created the iReadRoot.txt file, which has the same size as the root.txt file, which means we've effectively read the root.txt file. All right, so this was a guided walkthrough for the TriplAdvisor machine on HackMyVM.eu. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out!
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.